partner Jonathan and I are going to be talking about the physics behind a curveball. I'm basically going to be focusing more on the forces acting upon the curve or on the baseball, while my partner Jonathan is going to be explaining the different throws that you could do to cause a curveball. The basic force that I can think about that is acting upon the curveball is something that we actually learned in class, which is that as soon as something is released or thrown, there's an automatic pull to center the earth, which causes the ball to actually go downward as it's thrown in baseball. But there's also three forces acting upon it, which is Newton's third law, Bernoulli's principle, and the Magnus effect. Newton's third law is also something we learned in class, but just to recap, is that for every action, there's an equal and opposite reaction. And the way that this ties into the baseball is that as the ball is thrown, it is moving forward and the forces are pushing it back, which is causing it to slow down. So that actually gives it more cause of it to make a spin, so it could end up getting more speed so it can actually do the curve. Now, Bernoulli's principle states that as the speed of moving fluid, liquid or gas increases, the pressure within the fluid decreases. This actually could be tied into the air pressure on all sides of the baseball. So the curve of the ball is caused by the pressure on every side of the baseball being imbalanced. As I found in an article called Physics of the Curveball, they say that the air on one side will be moving faster than on the other, resulting in less pressure on the other side. So on the other side, there will be more air pressure because of the less velocity. And the higher air pressure pushes the ball sideways, and this results in the curve. Lastly, the Magnus effect. The basic concept is the commonly observed effect in which the spinning ball curves away from its principal flight path. This has to do mainly with the positioning of the stitches on the baseball. So the ball will cause pressure that will be greater on one side than the opposite side because of the stitches on the ball. And also on the article that I found, they say that once the air with higher pressure pushes the ball towards the side with the lesser pressure, which also causes the curve. So now my partner Jonathan is going to be talking about the different positions that you can hold and throw the baseball. And then we have a little clip at the end showing a professional baseball player throwing a curveball, just so you guys can see how it all comes into play and how the ball actually does curve because of all the way he holds it, the way he throws it, and the way that physics actually does act upon the baseball.
Hello, my name is Jonathan Palayo. My partner and I are doing the physics of throwing a curveball. Now, there's many different ways to throw a curveball, but I personally, like to throw it with my fingers against the seams like this. The key point to the curveball is to make sure that you are along the seams. Make sure you put the pressure on the seams, because what I do, my two fingers, I have my middle finger here and then my other finger right here, while my thumb is at the bottom of it. So when I throw it, this finger is going to push on the seams along with this one, while my thumb is pushing it up. Another way to hold it is also like this, with your two fingers in the middle, and you're just going to put pressure on the seams with both fingers going down, as long as your thumb going up again. So I just showed you your fingers spread apart or fingers close together, but the thumb is always pushing up against the ball. Now, another way that I have found is also to turn the baseball and hold it like this. So as long as your fingers are pressing down against the seam this way, while your thumb is pushing up. So when I throw the ball, I'm going to come across, but I'm also going to curve my wrist. We'll flick my wrist, so to create that push with my top fingers down, and then a push with my thumb going upward, so that the ball will then spin like this, and eventually it will drop.